Welcome to the blended learning version of the potato osmosis lab. You'll find the assignment here on the cell membrane and transport page. When you click on it, or you should have already clicked on it, it looks like this. Hopefully it looks like this. If it doesn't, you might have some problems. Hopefully you read through all this first part already and you are now ready to start the video, which is what you're watching right now. I took some pictures of the potatoes and videos, and hopefully just to walk you through what was supposed to happen if you were actually doing the lab. So here are some chunks of potato that I cut into 1 centimeter cubed, 2 centimeters, and 3 centimeters, but not cubed. This face here is 1 centimeter by 1 centimeter on both of them. The length is 3 centimeters. Here's another look at them. Can you hear me now? And then all those 3 of those chunks would each be placed into, there'd be lots more than 3. There'd be 3 in this cup, 3 in each cup. Okay? Each cup would have 3 potatoes in it. I'll show you some potatoes in there in a second. Here's the 0 molar cup, so just water. Here's the 0.2 molar cup and 0.4, 0.6 molar solution, 0.8 molar solution, and the 1.0 molar solution of sucrose. Again, this is the carbohydrate or sugar that's going to kind of balance out with the starch that's in the potato. So there's the setup with the potatoes in there. And just to show you kind of what occurred in just measuring, massing these little chunks. There's the 2 centimeter chunk, and then 5.4 grams for the largest chunk. And then again, they were placed into the cups and they sat overnight. But before you finish, you clean up the lab station, right away right there, and wipe down the table. Once again, right away. You guys would all be doing this. Nice job. Alright, here's the important part. On the second day, the masses were taken for each potato and averaged out. And the most important part is right here. Average change in mass for all the chunks. Okay, chunks sitting in 0 molar or just water, 0.2 molar, 0.4 molar, and so on. You can see here that these guys gained mass overnight, and these guys here lost mass overnight. 0.0 and 0.2 were sitting in hypotonic solutions. 0.4 through 1.0 were sitting in hypertonic, hypertonic solutions. So somewhere in here is that in between positive and negative. Somewhere in here is the isotonic conditions, and that's where we go to our graph. Again, the graph is just these points here plotted out on the y-axis, and then the different concentrations on the x-axis. 0 on the y-axis is up here, and then I filled in the rest, positive 10 through 40, negative 10 through 40, to represent these numbers here. Average change in mass. Positive numbers are increase, negative numbers are decrease. And the part about this graph I want you to focus on is right here, where that graph crosses the 0 line, right? And that is somewhere in here between 0.2 and 0.4 to go from positive to negative. Somewhere in there is 0%. And that's what this graph shows you. Right there is 0% change in mass. So if we were to take this solution, whatever it is, 0.25 or 0.26, and have a cup with potatoes in it, we would expect to have 0% change in mass. In other words, they are in isotonic conditions. The concentration of carbohydrate is the same or very close to the same inside and outside the potato. So we have 0 change in mass. So again, somewhere in here, which kind of makes sense with our data. Pretty close to 0.2, but between 0.2 and 0.4 is where that graph should cross 0, and that's where it does cross 0. So, come up with your conclusion and fill in some blanks, and you are